Welcome to the Explainer. Today, we're going to crack a classic GCSE computer science question. But look, we're not just going to give you the answer. The goal here is to get inside the examiner's head so you can snag every single mark. We're going to break down question 9C piece by piece.
Okay, let's dive right in. First things first, we've got to really understand the problem they're throwing at us. This is a brilliant example of a question that's testing a few different skills at once. So let's see what it's really asking for.
So here it is, our two-part challenge, and it's worth a pretty hefty 7 marks. You've got 2 jobs. First, write a validation algorithm. You've seen this stuff before. And second, you've got to prove it actually works by picking the right test data. Nailing both of these is absolutely key if you want to hit those top grades.
So this is the big question, right? How do you make sure you get every single mark? Because it's one thing to write some code that kind of feels right, but how do we know for sure that we've ticked every single box the examiner has on their list? Well, the secret isn't just about being a coding whiz, it's about having a strategy and learning to see the question through their eyes.
So before we even dream of writing a single line of code, our first job is to pull this prompt apart. We need to find all the keywords, all the constraints, and basically build a little mental checklist. This is the foundation for our perfect answer. You gotta get this right.
And just like that, we've turned that big block of text into a simple to-do list. We need an input for the height. We've got to validate it between 40.0 and 180.0. Super important, inclusive means 40 and 180 themselves are totally fine. And finally, we spit out either valid or not valid. Now here's the thing. Every single one of these points is basically a mark waiting for you to grab.
Okay, now for the fun part. Let's build this perfect algorithm. And I'm going to let you in on a little secret weapon here. We're going to use the official mark scheme as our guide. I mean, it literally tells us exactly what the examiner is looking for. It's like having the answers before the test.
And here you have it. This is the official checklist, right from the mark scheme. I've just simplified the wording a bit. 4 points, 4 marks. It's that simple. Our algorithm has to do these 4 things, no more, no less. It's got to take an input, check that it's greater than or equal to 40, check that it's less than or equal to 180, and then it has to print the right message. That's our blueprint.
All right, let's build this thing piece by piece using that checklist we just made. Step 1, get the input from the user. Easy enough. Now, steps 2 and 3 are the real heart of our validation. We need to check if the height, h, is greater than or equal to 40, and at the same time, if h is less than or equal to 180. That and is so important. Both things have to be true. And then, based on that one check, we get to our outputs. Print valid if it passes, or not valid if it fails.
And there we have it. That's the finished product. See how clean that is? By building our logic directly from that mark scheme, we've created a solution that is not only clean and efficient, but it hits every single target. This isn't just an algorithm that feels like it should work. This is an algorithm that is guaranteed to score all 4 marks. We've just systematically ticked every single box.
But wait a minute. Writing the code is really only half the job in computer science, right? You have to be able to prove it works under all sorts of conditions. And that's where the second part of the question comes in. And honestly, it's where a lot of people can lose some really easy marks.
So this brings us to the final 3 marks for this question. And it's all about showing that you know how to test your code systematically. You just have to give one good example for 3 different types of test data.
And this table just perfectly lays out the 3 types of test data that examiners are always looking for. You've got normal data, that's your everyday, sensible, expected input. Then you've got boundary data, which is all about testing the absolute limits of your valid range. This is so important for catching those classic off by 1 bugs. And finally, erroneous data. This is anything that should fail. Stuff that's way outside the range, or maybe even the wrong data type altogether, like text instead of a number.
Okay, so with those definitions crystal clear in our minds, let's actually apply them. We just need to pick one perfect example for each of these 3 categories: normal, boundary, and erroneous. That's all we need to do to fill out that test plan and lock in those final 3 marks.
And here's what a perfect set of answers looks like. For normal, we'll pick something safe, right in the middle, like 100. For boundary, we've got to pick one of the exact limits, so let's use 40.0. That should be valid. And for erroneous, we want to pick something that's just outside the range, something like 39.9. That should definitely be invalid. These 3 choices show you've really thought about how to test properly.
Okay, let's pull all of this together. What's the master strategy we've just walked through that you can use on pretty much any programming question they throw at you in the exam?
It really all comes down to this 5-point checklist. Number 1, always deconstruct the prompt. Pull out every single constraint. 2, think in marks. Connect each of those constraints to a point on your final score. 3, use the mark scheme as your literal blueprint to build your logic. And then 4 and 5, when it comes to testing, and this is crucial, always test the exact boundaries and then test just outside them. This systematic approach isn't about luck, it's about making sure you maximize your marks every single time.
So there you have it, a complete takedown of a 7-mark question, showing you not just what the answer is, but why it's the right answer. You now have a really powerful strategy to tackle any validation and testing problem you face. The only question left is, what question are you going to apply this to next? Thanks for joining me on The Explainer.